Hello, my dear students and the rest of the learners. Welcome to part 29 of a 7-part series of tutorials in computer structure and programming in C and Pascal. This is section 8 of 13 in the topic data structures. My name is JM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at the data structures called pointers, where I will discuss or introduce the pointers. We shall also learn how to declare pointers, how to initialize pointers. We shall also look at the procedures new and dispose in Pascal, and then we shall look at pointer expressions and pointer arithmetic. We shall also look at pointers of an array in C, and also what we call pointers of structs or records in Pascal. Let's commence by looking at what pointers are. A pointer is a variable which contains or whose value is a memory address of data. In this case, an address is used to refer to a variable instead of its name. So, a pointer contains an address of a variable that contains a specific value. A variable name directly references a value, and a pointer indirectly references a value. When data is organized in memory, each byte in the memory is associated with a unique address. The address of an object is the address of the first byte of the space allocated for it. The address specifies all the bytes allocated to the object. The number of bytes referenced to by such is an address, and therefore the number of bytes referenced to by a pointer is usually an address, and that address is called its scope. For example, if an address A represents an integer location, then the scope of A is 2 bytes in Pascal or 4 bytes in C. The scope of an address is relevant only when the address represents valid data. Referencing a value through a pointer is called indirection or dereferencing. Therefore, the process of accessing the value pointed to by a pointer variable is called dereferencing. The following are some of the reasons of using pointers in programming. Number one, we can use a pointer to point to different variables or objects. This, or therefore, the programmer just needs to declare one pointer and then have it point to different objects when need be. The programmer in this way can use one name to refer to different objects, and this makes programming much easier. Secondly, pointers are useful in dynamic memory management. That is, the ability for a program to obtain more memory space at execution time and release memory when it's no longer needed. Number three, the pointers are more efficient in handling of complex data structures like arrays, structs, linked lists, stacks, queues, trees, amongst others. Number four is that pointers reduce the length and complexity of programs. Number five, pointers increase execution speed by enhancing the ability of a program to manipulate data. Let's now look at how we declare pointers. Declaration of pointers. The syntax for declaring a pointer in C is as follows. Data type followed by variable name and a semicolon. Then referenced data type. The referencing operator, pointer name. That is referenced data type, then pointer name. For example, int score. Then int score pointer. So as you can see, my dear students and the rest of the learners, we first of all have to have a variable declared, and then we declare a pointer to that variable, or a pointer that will be used to refer to the content of that memory location referred to by the variable name. It can be diagrammatically represented as follows. Variable score, then a pointer to the variable. So in this case, as you can see, the variable score or the name score directly references a variable that contains a value, for example, 70, while a pointer to the variable indirectly references the value in that memory location. Like in this case, score pointer indirectly references a score that contains 70. The reference data type is the data type of the variable whose address can be stored by the pointer. For example, the pointer called score pointer is for storing the memory address of an integer. Storing the memory address of an integer. For example, 70 stored in the variable called score. Pointers, just like all other variables, must be defined before they can be used. The definition, for example, int score pointer specifies that the variable score pointer is of type int. That is, a pointer to an integer. Wherever you see the referencing operator accompanied by the type of variable, for example, type int, then the referencing operator, that reads a pointer to that type. For example, a pointer to an integer. And it's read as score pointer is a pointer to int, or score pointer points to an object of type int. The syntax for the definition of a pointer in Pascal is as follows. So we have type, pointer type equals to, then caret, reference data type. And then we have variable, pointer name of type, pointer type. For example, type score pointer points to an integer or a memory location containing an integer. Therefore, type score pointer equals to pointer to integer. So score pointer points to integer. And then variable score of type score pointer. So that's one way of defining a pointer in Pascal. Or we can have it as variable pointer name, then caret pointer type. For example, variable score pointer 1 is a pointer to integer. Variable score pointer 1 is a pointer to integer. Or score pointer 2 is a pointer to integer. The above declarations mean that number one, a new data type, which we are calling pointer type, is declared that points to data items of type referenced data type. Secondly, the caret before referenced data type denotes pointer to. Thirdly, a pointer variable is then created called pointer name, which is of type pointer type. From the above example, score is the variable name of score pointer. It points to a data element of type integer. Therefore, a pointer type variable references a variable of the type specified in the pointer type declaration. Pointer data type is the name or is the same type as the type of variable it points to. So if a pointer points to an integer, its type becomes integer. Therefore, pointers are of type integer, type real or float, type char, etc. How do we initialize pointers? When the pointer variable is declared, it must be assigned a value. That is, it must be meant to point to a data element of the reference data type. Remember that pointers generally store memory addresses of the variables assigned to them. And therefore, when a pointer variable is declared, it may contain an arbitrary value. It should therefore be initialized to either 0 or to an address. If a pointer is declared that does not point to any value in data, it contains the value nil in Pascal or null in C, denoting an invalid address. That means it points to nothing. But remember, it will contain something, but something that is not meaningful and something that does not really refer to what the programmer wants. Therefore, a pointer that points to nothing is initialized with null in C or nil in Pascal, and these are reserved ones in C and Pascal respectively. Null or nil represents a value that cannot refer to a valid address in memory. The value 0 is the only integer value that can be assigned directly to a pointer variable. It's equivalent to null, but null is preferred. The two pointer operators that are used when you want to initialize a pointer by assigning it a variable address in C are 1, the address operator, which returns the address of its operand. It's used to access the address of a variable. So whenever you want to address or to refer or to access the address of a variable, we use the address operator. For example, printf, integer identifier, address operator or address for score. So this statement means that you pick the address of the variable called the score and you display it on the screen. You write it out. This will output the memory address occupied by score. To make a pointer store the address of a variable, we assign the variable's address to the pointer using the address operator as follows. So in this case, we have the address score. So this simply means that pick the address of the variable called the score and assign it to score pointer. Secondly, we have indirection operator. It returns the value of an object which its operand, that is a pointer, points to. So you can access the value stored by a variable using a pointer instead of using the name of the variable. But remember, we must make use of indirection operator. This is known as dereferencing the pointer. This is done using the reference operator followed by the pointer's name. For example, the indirection operator score pointer. This one, or this part, simply means that access the content of the memory location pointed to by score pointer and assign that value to the variable called mark. It is the same as picking the content of memory location called score and assigning it to the variable called mark. And both will assign value 70 to mark if 70 was input to variable mark. For example, or that is through a statement like 70 assigned to memory location called mark. So we can access the contents of score either using the name score, that is the variable name score, or through the pointer such as score pointer, that is a pointer that points to that variable called score. So we indirectly access the content of memory location called score through the pointer that points to it. Then the reference operator is used in C both to declare a pointer and the reference a pointer. But in Pascal, the reference operator is called the caret. For example, to assign the address of a variable called value 1 to a pointer variable called score, we do it as follows. So this statement, my dear students and the rest of the learners, simply means that pick the memory address of the variable called value 1 and store that address to the variable called score. So this assigns the address of a variable value 1 to a pointer variable called score. A pointer variable called score. In this case, the pointer variable score points to the variable value 1, and when the value referenced by score is accessed, the value stored in variable value 1 is obtained. If we have a Pascal statement like value 2 assigned to score pointer, this will simply mean that the value pointed to by the pointer to value 2 will be displayed with a statement like right line score pointer, right line score pointer. So this statement here simply means pick the value stored in memory location called value 2 and assign it to the pointer. In other words, we are initializing the pointer called score with the value stored in memory location called value 2. So the value pointed to by the pointer to value 2 will be displayed by the statement right line score pointer, or right line or write out whatever that the pointer called score is holding. The following is a sample program in C implementing pointers. That's our preprocessor directive, then our main function. Then we have declared a variable called score of type int and another variable called product of type float. And then we declare a pointer of type integer called score pointer. And we also declare another one called product pointer, which is a pointer of type float. We then initialize pointer with the score variable address. So this statement simply means that pick the memory address of the variable called score and assign it to the pointer called score pointer. So we are initializing the pointer with score variable address. So score pointer is now referring or pointing to the variable called score, because we have assigned to it the memory address of the variable called score. So if we write out a statement like enter a whole number, and then we read a value, or you input a value, that value will be picked and then it will be stored in the memory location which is being pointed to by the pointer called score pointer. Remember, currently score pointer contains the address, the memory address of the variable called score. And therefore, this statement is the same as reading, is the same as address score, is the same as address score. So simply, this statement using score pointer indirectly stores the value entered to the variable called score, but through the pointer. So once the value is entered, the compiler will check, or the processor will check the address of the pointer called score pointer, and then it will go to that address, or to that address, and store that value which has been entered there. So if we display the message, the value entered into the variable score is score, this will automatically give us the value that has been indirectly stored in the variable called score. So when we output the score, it will display the value which has been entered. So the statement, the value entered into the variable score is, it will pick the value in that variable called score, which is of type integer, and display it, and then drop one line. Then this other statement, this statement reads, or means that initialize the pointer called product pointer with the variable address, or with the address of the variable called product. So it simply means pick or read the memory address of the variable called product and assign that address to the pointer. Assign that address to pointer. So it is initializing product pointer with the product variable address. So this pointer called product pointer now points to the variable, or to the memory location, points to the memory location for the variable called product. This is how we make pointers to point to whichever variable that we want, as long as those variables are of the same type as the pointer. Then this statement simply means that product or pointer is being assigned to product. The product or pointer is being assigned to product. In other words, it simply means that read the value which is being indirectly referred to by the pointer called score pointer, multiply it with the value which is being indirectly referenced to or pointed to by the pointer called score pointer. So the product of the two is stored in product. In other words, this statement simply picks the content of the memory location being pointed to by the pointer called score pointer, and it is being multiplied by itself, and the results are assigned into the memory location called product. So this statement is like multiplying, it's like multiplying product, or is this statement is like multiplying score times score. That is the value of memory location called the store or score multiplied by itself. And that is what is stored in the memory location called product. So we indirectly referring to what score pointer points to. We indirectly referring to the memory of the variable being pointed to by score pointer. And as it stands for now, score pointer has been initialized with score variable address. So whatever is in the variable called the score will be picked and be multiplied by itself, and the results will be stored in the variable called product. And therefore, this statement, the product of value entered is whatever that product pointer is indirectly referring to. In other words, this statement will display the content of the memory location which is being pointed to, or which is indirectly. Let me rephrase it properly. This statement, the product of value entered is, will pick the content of the memory location being pointed to by the pointer called product pointer and display that value. So what will it display for now? Remember, in this statement here, we have initialized product pointer with product variable address. And therefore, our product pointer will output this value, the value which is stored in memory location called product. Why? Because product pointer points to the memory location of the variable called product. And that becomes the end of our program. So the following is a sample program in Pascal implementing pointers. So our program is called pointers. We declare uses because we are going to manage the screen, like clearing the screen. And then we declare a pointer. So it is type score pointer, and it points to an integer. Then a variable called the score, which is of type score pointer. Then we have value 1 and value 2 variables of type integer. So we begin, we clear the screen, and then we display the statement. The current content of score pointer is. So we display whatever is contained in the memory location for our pointer. So we know that our pointer called the score is pointing to nothing. So it will display whatever invalid content, or whatever content that is there, because it has not been initialized either to 0 or to any other value. And then we have a nil being assigned to score. Nil is being assigned to score. This is initializing the pointer on the score. So we initializing the score pointer with the nil. So the next statement, and now it is, we pick whatever is in the variable, whatever is in the variable for the pointer. And in this case, our pointer has been initialized to nil, and therefore we are going to have a value displayed. For example, a zero, a nil value. Then right line, enter a value in a variable score. So we pick whatever the user will enter, and then we store it in the memory location, which is being pointed to by our pointer score. We then write out the value referenced by pointer variable score is, so this score pointer, it will pick whatever is in the memory location which has been pointed to by the pointer called the score. And that is what will be output. That is what will be output. Remember, a value has already been stored there. So that value is what will be displayed. Then we initialize the pointer called the score with the memory address of the variable called the value 1. So we are making the pointer called the score to now point to the variable called value 1. So right line, after initialization, the current content becomes, so this statement will display whatever that is currently in the memory location, which is being pointed to by score, and that will simply be the content for the variable for the value 1. Then enter a value in variable value 1. So we read a value. Now, once we read this value, it will be stored in the memory location for the value 1. So if we initialize, or if we assign the current content of value 1 to the pointer, or which is score pointer, the score pointer, it simply means that we are now referring to the content of the memory location called the value 1 through the pointer or the score. So after initializing pointer, this statement will be displayed. After initializing pointer with the value 1, it now accesses. So we display whatever that pointer is currently accessing. That is whatever score pointer is currently accessing. And what is it accessing? It is the content of value 1. Then we initialize the pointer with value 2. In other words, we are now making score pointer to point to the memory location for value 2, or the memory location called value 2. And therefore, if we request the user to enter a value in variable value 2, that value will be picked, and then it will be stored in the memory location, which is being pointed to by the pointer called score. So we are indirectly going to, or we indirectly referring to value 2 when we use the pointer score. So score pointer, we know it's currently pointing to the memory location for the variable called value 2. And therefore, the value which is entered will be indirectly stored in the memory location called value 2 by the pointer. So we display the statement. After initialization with variable value 2, the pointer now accesses. So we output the content of the memory location, which is currently being pointed to by score. Remember, score currently contains the memory address of the variable value 2. And therefore, whatever is contained in that memory address is what will be displayed. Then we pause on the screen. Remember, this statement I said is for pausing the screen, allowing the user to read the output, and then we end our program. Let's now look at procedures new and dispose in Pascal. The dynamic allocation of memory is done using the procedures new and dispose. The procedure new takes a pointer variable as an argument, and it creates a new variable of the same type and assigns the address of the new variable to the pointer variable. The variable that's created is different from normal variables because it does not have a name. Rather, it can be accessed only by referencing the pointer. The memory space used for dynamic allocation is taken from a part of the main memory, which we call the heap. A heap is the area in the main memory for dynamically allocated storage. Therefore, new assigns memory space from the available space in the heap. When there is no space in the heap for a new variable, procedure new returns nil. The amount of memory allocated depends on the type of the pointer variable. This information is obtained from the declaration of the variable. Dispose deallocates the memory assigned to a particular variable. When a variable is declared statically, the memory allocated to it at the beginning remains assigned to it until the program terminates. So this memory cannot be used for any other purposes, even if the use of the variable is over during the execution of the program. If the variable is dynamically allocated, the storage assigned to it can be deallocated soon after its use has been completed. And therefore, when the actual memory requirements are not known in beforehand, especially in large programs, memory shortage may arise. The dispose procedure releases the memory area allocated to the pointer variable supplied as an argument. The released memory is returned to the heap. The deallocated memory is usually marked as free so that it can be deallocated. The following is a sample program allocating and deallocating memory. So our program is called new dispose. Then we declare a pointer. Our pointer is score pointer. So type score pointer, which points to integer. Then we have variable called score of type score pointer. We begin. We request the user to enter a value for score. Then we read score. We read the value, or we pick the value entered, and we assign it to the memory being pointed to by the pointer score. Then, in other words, let me rephrase this part. Enter a value for score. So we pick some memory location. We pick some memory location and call it score. From the available memory, we pick a portion of it and we name it score. And then we read a value. We read a value from the user, and that value, we store it through the pointer into that portion of memory that has been set aside to be used by the pointer score. So we then display the statement. The value referenced by a pointer variable score is, we pick the value that our pointer is pointing to, and we display it out. So whatever value that is in the memory location that is called score, that the pointer is pointing to, will be output here. Will be output here. And then we do away, we erase the content in the memory location that we have created called score, because we already with it. We already done with it. So we no longer need it. So we dispose it. Then read line is to pause to allow the user to see the results, and that is the end of the program. Now, what is most important here, my dear students and the rest of the learners, is to see how we pick a portion of memory, we name it. Once we are through with using it, we discard it or we dispose it. So new score, dispose score. The variable score is assigned an address by the function new. So the value that is accepted through the readline statement is stored in this location. The location whose address has been assigned to the variable. The storage is freed after completion of the required task by using the dispose function. Let's now look at pointer expressions and the pointer arithmetic. Pointers are valid operands in arithmetic expressions, assignment expressions, and the comparison expressions. A pointer may be incremented or decremented. It is incremented using the increment operator or decremented using the decrement operator, and an integer may be added to a pointer using either the addition operator or and assignment operator. That's assignment and operator. An integer may be subtracted using the subtraction operator or the assignment subtract and assign operator, assignment subtraction assignment operator. And one pointer may be subtracted from another. A pointer can be assigned to another pointer if both have the same type. For example, if we have the following declarations in C, we have declared three variables of type integer, one called score1, the other one score2, the other one total. Then, if we have also declared two pointers, one pointer called score pointer, that is score pointer 1, and another pointer called score pointer 2. And then we initialize them as follows. We pick the memory address of the variable called score1, and we assign it to score pointer 1. So in other words, we are now making our pointer called score pointer 1 to point to the variable or the memory location for the variable called score1. And then we pick the memory address of the variable called score2, and we assign it in the memory location called score pointer 2. In other words, we now initialize score pointer 2 with the memory address of the variable called score 2. So we are making score pointer 2 point to the variable of the memory location for the variable called score 2. Then the following expressions would be valid. 70 assigned to the memory location being pointed to by score pointer 1. Score 1, or the content of memory location called score 1, is assigned to the memory location being pointed to by score pointer 2. The content of memory location being pointed to by the score pointer 2 pointer being read and assigned to the memory location being pointed to by the pointer called score pointer 2. Then this statement means, or is, pick the content of memory location being pointed to by the pointer called score pointer 2, multiply it with the content of memory location being pointed to by score pointer 1 pointer, and assign the results into the memory location being pointed to by the pointer called score pointer 1. Then this statement means that pick the content of the memory location being pointed to by the pointer called score pointer 1 and multiply it with the content of the memory location being pointed to by the pointer score pointer 1, and the results assign them into the memory location being pointed to by the pointer called score pointer 2. Then this statement means pick the content of the memory location being pointed to by the pointer called score pointer 1, then subtract 100 from it and add the results to the content of the memory location being pointed to by the pointer called score pointer 2, and the totals or the results assign them into the memory location called total. Let's now look at pointers of an array in C. Arrays and pointers are intimately related in and may often be used interchangeably. An array name can be thought of as a constant pointer. Pointers can be used to do anything involving array scripting. Since the array name without subscript is a pointer to the first element of the array, we can set pointer equal to address of the first element in an array by any of these statements. For example, assign the content of the memory location called scores to score or to scores pointer. And then this other statement means that pick the content of the array called scores whose subscript is 0. Pick the content of the memory location or the memory address, or in other words, pick the address of the first element in the array called scores. Pick the memory address of the first element in the array called scores and assign that address to the pointer called scores pointer. This is like assigning the address of the array called scores into the memory reserved for the pointer called scores pointer. Array element 3 can be alternatively referenced either as scores subscript 3 or using a pointer to refer to the same. That is, pick the content or read the content of the memory location in the array whose subscript is 3 that is being pointed to by the pointer called scores pointer. That is scores pointer 3. Just as the array element can be referenced with a pointer expression, the address scores subscript 3 can be written with a pointer expression scores pointer plus 3. In this case, 3 is an offset. So that means you can refer to the first element or the element whose subscript is 1 by saying scores pointer plus 1. The second one scores pointer plus 2. The third one scores pointer plus 3. In general, all subscripted array expressions can be written with a pointer and an offset. Pointers can be subscripted exactly as arrays. For example, if scores pointer refers to an element whose subscript is 1, the expression scores pointer 1 would refer to the array element scores whose subscript is 1. This is referred to as pointer or subscript notation. To copy an array to another, as long as both are of the same type, we can do it as follows. Pick the content being pointed to by the pointer called ages pointer and assign it to the memory location whose value or whose address is in scores pointer. In other words, we can say this statement means pick the content being pointed to by the pointer called digits pointer and assign it into the memory location being pointed to by the pointer called scores pointer. Or we can simply say pick the content of memory location called ages, assign it to the memory location called scores. The size of operator is used to determine the size in bytes of an array or any other data type during program completion and returns the total number of bytes in the array as an integer. The size or this size can be assigned as an int variable. For example, size of scores. Assign that size, the memory location called size. In other words, compute the size of the memory location called scores and assign the results in the memory location called size. The number of elements in an array can be determined with the size of operator using the following expression. My dear students and the rest of the learners, kindly note that scores in this context, by the look of it, it can refer to the array called scores. It can refer to the array called scores. So size of scores, the total or that size, the size of that array, assign it in the memory location called size. So the number of elements in an array can be determined with the size of operator using an expression like this one. Size of array name whose subscript is 0 divided with the size of array name. In other words, this statement can be read as size of, or calculate the size of the array name. Divide that for the results with the size of array name 0. The size of that array name subscript 0. For example, size of scores divided by size of scores subscript 0. This expression determines the number of bytes in an array and divides that value by the number of bytes used in memory to store the first element of the array. We can also have arrays or pointers. In this case, each element in the array can be accessed by its own pointer. For example, if you have an array of variable declared as int ages size 5, then we can declare an array of pointers for the above array as follows. That is, reference operator ages pointer 5 of type int. So this simply means this is an array of pointers. How many? Array of pointers pointing to 5 elements. And those elements are of type integer. After that, we can initialize arrays of pointers with an array element address using a for loop as follows. Like, for example, for initialize I to 0, then find out if the value of I is less than 5. If yes, do the following. Pick the content of the memory location, or pick the address, pick the memory address of the first element in the array. That is element whose subscript is 0 in the array called ages. Assign that the memory location called ages pointer 0. In other words, pick the address of the first element in the array and assign that address, that memory address, to the address of the first pointer, or pointer 1, of the pointer pointing to the first element, the array. Then increment counter by 1. It becomes 1. Check if 1 is less than 5. Yes. If yes, pick the address, the memory address of the second element in the array called the ages. Pick that memory address whose subscript is 1 and assign that address to ages pointer 1. Then increment the counter to 2. Is 2 less than 5? Yes. Then pick the address of the memory location of the array element whose subscript is 2, that is age is 2, and assign that address to the memory location that is pointing to 2, to address 2, that is age is pointer 2, and that will continue until I is no longer less than 5. We exit the loop. We can also pass an array of pointers to a function as follows. If you have a function, for example, called bubble, that is void bubble, whose parameter is 1, and this parameter is of type pointer. It is an integer type. So this is a pointer to the array called ages pointer, and it is of type integer. In which case, its call statement will be as follows. Bubble ages pointer. So ages pointer is the parameter. And that parameter, of course, is a pointer. So we are invoking the function called bubble and passing to it the content of memory locations being pointed to by the pointer called ages pointer. The following is a sample C program implementing a pointer to an array that is used to read 7 values into an array, perform bubble sort of the array, compute sum of the array elements, and display the sorted array and the sum of the elements. So that's our preprocessor directive for input-output, then a constant of size 7. Then we have a function prototype called input scores, which is receiving a single parameter, which is of pointer type, which is a pointer type, or which is a pointer of type integer. Then we have another function prototype called bubble, and it is receiving one parameter, which is an array of pointers, or which is a pointer of type integer. Then this another function is void display array, or it's a function called void display array, which is also receiving one parameter. This parameter is a pointer of type integer. Then you have our main function. Then we declare a variable, or we declare an array called scores, whose size is 7. Then we also declare a pointer of type integer, called scores pointer. Then we initialize scores pointer with the array. In other words, we initialize pointer with the array. We assign the memory addresses of our array, or of our elements called, our elements in the array called scores. We assign them into score pointer. In other words, we initializing score pointer with memory addresses of the variable called scores, which is an array. And then we invoke the function called input scores by passing it one argument, which is scores pointer. That means we are passing the array of course, but with the pointer. Then we also invoke the function called bubble by passing into it the pointer called scores pointer, which of course is pointing to an array. Then we invoke the function called display array by passing into it one parameter, which is scores pointer. And the scores pointer is a pointer, integer. Then once that is done, we turn back the operating system in the program. So our function definitions are as follows. Bubble, the function is bubble, is receiving one parameter, pointer of type integer, pointer of type integer, which name is scores pointer. This function is for sorting elements, and we have our local variables there. We have the for loop for controlling the operations. Remember, we discussed about the bubble sort and the sorting techniques, and therefore I will not really explain about the same at this point. The only purpose of this function is to demonstrate how we use the pointer to indirectly refer the elements in the array. So we have the for j equals to I plus 1, j less than size. If j is less than size, do the following. So in other words, when I is equal to 0, that means 0 is less than 7, the following. Initialize J with current content of memory location record I with 1. Assign it to J. Then check if the content of J is less than size. If yes, do the following. Compare if the content of the memory location record of being pointed to by scores pointer plus J is less than scores pointer. In other words, if the current content of the first element, which is being pointed to by scores pointer plus 1, is greater than the content of the memory location being pointed to by scores pointer J, then do the following. Create a memory location record temp or assign the current content of the memory location being pointed to by scores pointer I to the variable called temp. And then pick the current content being pointed to by the pointer called scores pointer plus 1 and assign it to the memory location being pointed to by the pointer called scores pointer plus 1 or plus I. And then pick the content stored in the memory location called temp and assign it in the array at the subscript being pointed to by the pointer called scores pointer plus J. So we call that floating. Float the lowest element to the highest. So that's swapping. And that will continue. Once the first one is done, then we increment counter with 1. So J plus plus. Then we check, is the current content of the memory location on J less than size? If yes, we repeat this process here. We do the swapping. And that will continue until the value of J is no longer less than size. And then the inner loop will be exited. And we increment for the outer pass. Increment I in 1. That is I plus plus. So that is the next pass. And then we repeat the entire process again. And once we are through, we increment again. Remember, we continue implementing this inner loop. We continue until J is no longer less than 5. And then once that is all, once we are done, we go to the outer loop. Then we increment this counter. So this is purely for controlling the passes. This is for controlling the passes. And that will continue until our elements are sorted. And then this is function, which is called input scores. This is the one which is supposed to pick the elements. So those elements in the specific sections being pointed to the array by the pointer scores pointer as a local variable. Then we have controlling. We prompt the user to enter the first element. That is 0. Score 0. That's the first score. And then once the value is entered, we pick it. We pick that value, which is being pointed to, or we pick that value and store it in the memory location, which is being pointed to by the pointer on scores pointer. We increment with 1, or incremented with 1. And then we write out that value. We increment the value of counter with 1. So if counter was 0, it now becomes 1. Is 1 less than size? Yes. So we display the score 1. And the user enters a value. That value is stored in the memory location being pointed to by the pointer called the scores pointer. We increment it again once we are done. So in other words, this statement here is for reading the value and the user, and then it is being stored in the memory location being pointed to by a pointer called scores pointer from first element, second element, third element, etc. And once all that is done, all our values are being entered. So we display those results through the function called display array, which is receiving one parameter of like integer, and it is an array of pointers or an array to a pointer, or it's a pointer to an array. It's a pointer to an array. So it displays the element. So we have two local variables, I and the sum of type integer. And then we display the values. So the statement, the bubble sorted scores R will be written out. We initialize the value of sum to 0. And then we use the for loop within the content being referred to or being pointed to by our pointer code scores pointer, one element at a time. From subscript 0, that is I equal to 0, 1, 2, 3, and all our elements have been read from the array and displayed on the screen, spaced for characters. And then once that is done, or once we read the first element, we add, compute the sum by picking the content which is being pointed to by the pointer code scores pointer, the subscript. With subscript 0, we pick the value in the array or in the memory location in the array being pointed to by the pointer code scores pointer. We added the current content of the memory location called sum, and the results we get, we assign them back the memory location called sum. Then we move on within the next value, and then we add that value. So if it is subscript 1, we pick that value, and we add it to the current content of memory location called sum, and the results we assign them to sum. And that will continue until the elements are being displayed. Remember, this is for displaying, this is for computing the sum. And then we display, after we have done all the addition, we display the sum of the array elements. So the statement, or this statement will be displayed on the screen. And the sum of the array elements is, pick the current content of memory location we call the sum, and we display it out at that position. And with that, add the activity of displaying the elements in the array and outputting the results or the sum. Let's now look at pointers of structs or records. This is in Pascal. Structs in C, records in Pascal. We can declare a pointer of the struct or record type and then have it point to an instance of the struct. Simply, my dear students and the rest of the learners, pointers can be used to do everything that we have done from part 1 of this series of presentations up to now. It's just a matter of using a pointer to refer to a memory location, whether in an array, whether in a record, etc. For example, using the struct calculate, using the struct or the structure called calculate, or using a record calculate, defined below, you can be able to do the following. So we have a structure or a struct called calculate. It has the one member called score of type integer. There's another member called name, which is a character, an array of car. And then we can also do the same in Pascal. We can have a record in Pascal defined as follows. Type calculate equals to record. It has a member called score of type integer. It has another one called string, of which is an array or which is a string. Which another one called name. We have another member called name of type string, whose size is 10. Then add. We can declare an instance named and of calculate as follows. Like in C, we can have struct calculate and. That means and is an instance, is like an object. It's like a variable that will be used to manipulate the elements of the struct called calculate. Then in Pascal, we can also do it as var and of type calculate. We can declare a pointer named and pointer of type calculate as follows. In C, we do it as struct calculate and pointer, or a pointer pointing to the struct called calculate. So this is a pointer called and pointer. It points to the elements or the members of the struct called calculate. In Pascal, we have it as and pointer, which points to the memory location for the record called calculate. We can make and pointer point to instance and as follows in C. So this statement means get the memory location, get the address of the instance called and assign that address to the memory location for the pointer called and the pointer. That is in C, and you can do the same in Pascal, as you can see. So and pointer points to the memory location that is occupied by the record, whose variable is and. Just as we put variables, as we input variables in struct as follows in C, just as we say, like in this case, pick the content that has been entered or the value that has been entered and store it in the member for the score of the record, whose variable is and. So the same, if it was for the name or if it is the string, we do it as follows. Pick the value that has been entered, then store it in name, which is a member of the record, which is being manipulated by the variable called and. So pick that value or that name or pick that text, store it in the memory location in the member called name for the record. Or just we input variables in record as follows in Pascal. Within the item or within the element, and we store it directly through the variable called and. We store it directly into the record. We can also read the value entered as name, and then it is stored directly into the member called name in the record, which is being manipulated by the object or variable and. We can alternatively input the variables using pointer and pointer as follows in C. So we just replace the address, we just replace the object, with a pointer. Like in this case, this statement is that pick the value that has been entered, and store it in the memory location of the member called the score that is being pointed to by the pointer called and the pointer. This other one means that pick the value that has been entered for the name and store it in the memory location in the record being pointed to by the pointer called and the pointer. Or as follows in Pascal, and the pointer pointing. In other words, this statement means that pick the value which has been entered and store it in the memory location being pointed to by the pointer in the member or for the member called the score. This statement reads, pick the value which has been entered and store it in the member called name, whose record is being pointed to by the pointer called and the pointer. This is because the and pointer in C or and pointer in Pascal means the same as and since and pointer points to and. We can alternatively use the operator less than or minus greater than. I hope you remember what we said this assignment does or this operator does. So we can alternatively use this operator. We can alternatively use this operator to access a particular member of a struct instance that the pointer is pointing to in C. We can use that pointer to access a particular member of a struct instance that the pointer is pointing to in C. For example, if we have this statement, we are accessing the value, we are accessing the member, of the struct instance that the add pointer is pointing to. The following is a sample program implementing pointer of struct. So that's our pre-person directive. Then we have structure called fees, whose one member is called student name and is an array of car, soft type character. Then we have a member called amount of type float. Then we have our main function, and then we have an instance of our struct, and that instance is called student. You can call it a variable to manipulate the members of the function of the struct called the fees. Then we have a pointer that's supposed to point to the members of the struct called the fees. And then we initialize the pointer called student pointer with the memory address, of the members to the object or the members of a fees struct. This statement will be displayed on the screen. Enter the student name, then whatever will be entered will be picked and be stored in the memory location of the member called the student name, who is being pointed to by the pointer called student pointer. Then the next statement will be displayed on the screen as enter amount page. The amount or the figure which will be entered will be picked and it will be stored in the member called amount for the struct whose pointer called student pointer is pointing to. So the following statement will be displayed. The following is the student's fees status. So this statement will display student name, formatted 21 spaces, amount paid, formatted 23 spaces, and that will be done by this statement will pick the content of the member called student name in the struct whose pointer is student pointer. Then this other one will also refer to the value or the content in the memory location called amount, who is a member of the struct being pointed to by the pointer called student pointer. That value will be formatted to 23 spaces, with the two of them being reserved for the fractional part. Then we display a layout outline and our program. The following is a sample program implementing pointer of record Pascal. It's just the same as the one which I've shown you. The difference is only the syntax. So program pointer to record. That's the name of my program. Then we are clearing one record called fees detail. So type fees detail equals record. It has the following member called student name, string, whose size is 20. Then another member is amount paid of type real. And we have a variable to manipulate the content of that record. So this is an object or an instance of our record called a student of type fees detail. And then there is a declaration of a pointer which is supposed to point to the record called fees detail. So we are initializing. This statement is also doing initialization. It is initializing the content of the pointer with the address of the record called fees detail. So we begin. Let me do a correction here. I repeat here for the sake of your understanding, my dear students and the rest of the learners. Here we are declaring a variable for the student of type fees detail. And then we are declaring a pointer. We are declaring a pointer called the student pointer, which is supposed to be of type fees detail, So this is a pointer to the record, pointer of record. So it is a pointer of type fees detail, pointer of type fees detail. So here we initialize our pointer called student pointer with the record through the object called student. So the address of the object called student, the address of the object or of the variable called student, which we know is of type record, we initialize that pointer called student pointer, the address of student. Then you prompt the user. So in other words, at this point, we have now made our pointer called student pointer to point to the record called fees detail to student. So you request the user to enter student name, and whatever will be entered is picked, and then it is stored in the memory location of the record being pointed to by the pointer called student pointer for that member. I repeat, this statement simply means that whatever has been entered, store it in the memory location of the record. In the memory location, let me be specific, in the memory location called student name in the record being pointed to by the pointer called student pointer or student pointer. Then we display the other statement, enter amount paid. Then we read the amount which will be entered on the figure. That figure will be taken and then it will be stored in the memory location, called amount paid, which is a member of the record being pointed to by the pointer called student pointer or student PTR. Then we write out the following is a student fees status. So we write out the heading, student name, comma 10 to 21 spaces, and amount paid, comma 10 to 23 spaces. We then write out the student name. So we pick, this statement simply means pick the current content of the member called the student name of the record which is being pointed to by the pointer called the student pointer and formatted 21 spaces. Then this other one simply means pick the content of the memory location called amount paid, which is a member of the record being pointed to by the pointer called the student pointer, and format that output to 23 spaces with 2 of those spaces being reserved for the fractional parts. Then we end our program. And with that, my dear students, and the rest of the learners, we have come to the end of section 8 of this topic. You can continue section 9 of that in this topic by listening to the next part of presentation in this series. Congratulations for learning section 8 of 13 in the topic, data structures. You can also access section 1 to 13 of this topic, other topics in the computer structured programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on the subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me, and God bless.